Hi, I'm Bob Lefferts. Welcome back. This is episode 9 of Missile Command, How to Make Your Own Video Game. And I'm super excited about today's episode because I get to show you how to make your own object. We've been using objects all along because everything in Python is an object, but we've been using Python in a non-object oriented way for the things that we've been doing. So I'm going to start with a quick review of where we are on our frog hop program. So we're importing from mylib the move in direction A and the myEntry functions that we created earlier. And we put in a window, set the size of the window, put a frame, put a canvas, set some colors. We grab an image from our image and sounds folder that's over here on the side and turn it into an image we can actually use. We use the myEntry function in top frame to set some distance, delay, path length, path space, wire width, and path length. And then we defined a global dictionary. We're going to keep track of all the information about each of the frogs as we draw them. And then when you click, we create a frog object, a frog image on the canvas. And then we create all the information we want to track about that frog, its distance, the color, the delay, etc., inside of this dictionary. Then we go down when we want the frog to move. After a delay, we go ahead and move the frog. When we move the frog, we hit its coordinates. We move it in a random direction by a certain distance. We make sure we know the size of the canvas so we can clip the frog so it doesn't leave the canvas. And then we check to see if there's a space. If there's no space, it's a solid line, and we just draw a line with a certain color and width. Otherwise, we draw a line that has a certain color and width, but it has a dash property, which is essentially a line space combo. One line, one space. It draws a pixel and then a space, a pixel and a space. And then to keep track of the path, we append the line onto the path. And if the path gets longer than the length we want, we pop the first element off that list and delete it. And then the list doesn't grow anymore. And then we update the coordinate of the frog and then we do it again. And that's pretty much the whole thing. So now what we're going to do is we're going to do this with an object. We're going to create our own object. Instead of having a dictionary, we're going to create a class. So I'm going to put that class in here. That's how you define an object. We're going to call it frog hop. Okay. And then the first thing you have to do inside frog hop is build what's called a constructor, which actually builds the object. And so we're going to define a function that is underscore underscore. Don't use the int, that'll cause problems. It's init underscore init, where it is the initialization. And now here's where we define which variables we want to pass it. So we want to pass it a tuple, a point, where we want to draw the frog. We're going to create it, where we start it. And then we're going to pass in the values, the objects that we want to grab, have all the values grabbed from. So we'll just call this distance. We'll call it delay. We'll call it line, space, width, length, and we'll add a color. Those are the properties that we want to set on this thing. And then instead of using a dictionary down here at the bottom where you have to put in these strings, what we do is we just say self. Now here's the reason for self. When we create an object, it's that object is just going to be a pointer to memory. And so what happens in the programming in Python, they pass that variable in as the first argument in the list when you call a function. So the self is basically the memory location where all the rest of the data is, and now we're trying to have a constructor that creates it. So we're going to say self dist is just going to be the integer of dist dot get. So we're going to go to that we'll point to a canvas widget. So right now the way they're defining this is this entry is a canvas widget. We're going to get its value and set the distance. So this self.dist is just like this frog.dist, except they use the dot to delimit between the memory location where self is and the thing that's in the data structure underneath, which is the distance. And so then we're going to duplicate this, and we're going to change dist to delay, and we're going to change dist to delay. Wish I could type. And then we're going to change delay to line, and then we're going to change line to space. So we're getting all the values off the objects in the GUI, space. And then we're going to do width. And then we're going to do width. And then we're going to do length. And this is going to be length. This should actually show up with a preview. And then the last thing we're going to do is self.color is just going to be the color that we pass in. Okay? And then we need self.path. And that is going to be an array, right? So we're going to create an array inside, just like we did down here. We're going to create an array with self.path. Now, after we create the object, then canvas after self.delay. So we have the delay that's been stored in this variable self. We want to call the move command. So it's called self.move. So we want it to move. And now we need to define move. So move is going to have no arguments other than the value of self that gets passed. And this is where we want this object to move. And so we're going to grab all the stuff we did down here in the hop function, and we're going to copy it because we want to do exactly the same thing, but now we want to do it referencing the object itself. So what we can do here is this is no longer frog. This is, oh, we didn't create the frog. Let's create the frog. Self.frog is equal to canvas create image xy frog.png. Okay, and now we have x comma y. We're up here, we have xy. So what I'm going to do is I'm going to say x comma y equals xy. So I'm going to unpack that tuple and pass the x and y values down to the canvas. So now we've created the frog on the canvas. So with this memory is, just think of it as a memory pointer to the object. The object's frog is the item that was returned from the canvas. So now down here, to get that frog, it's no longer a variable passed frog, it's self.frog, because when we do the self.move, it passes self into the function. We get it here, self.frog is the frog. This is now simpler. Instead of all this goopy goggly goop, we type self. Now notice, it knows all the things that are inside of self because they're defined up here. So it knows that there's a distance. And then we do the random direction, and then we do the XY. We get the canvas width. We clip it. And now this, instead of frog data, all this gobbledygook, it's self.space. And it knows about self.space. And then this color is just going to be self.color. And it knows about color because it knows it's defined in this structure up here. So by using object-oriented programming with all this structure, it gets to be very simple. Self.width. In the case where there is a line, this is going to be self.color. This is going to be self.line. And this is going to be simply self.space. And then finally, the width is self.width. And now this path, instead of being a pointer to a dictionary itself, it's self.path. And then I append the line to it. Now here, self.path is the list. Self.path. And here is self.length. Self.length. So if the path gets longer than the length it's supposed to be, then we take the first element off that list, which we can actually do this. If you use self.path, it knows that it's a list, so you can do pop 0. Very convenient. All that stuff works fantastic. Here, we need to update the position of the frog on the canvas. It's actually self.frog. And here, we want to wait for self.delay. Self.delay. And here, we don't want to call a function, but we want to actually call the move function again. So we do self.move. And the cool part is here, right, is that it's going to pass the self value in so that when it comes in, it knows the exact memory location of the whole object itself. And we are done defining a frog hop object that we can instantiate, and it'll move all by itself. So what we're going to do is instead of this click event, I'm going to steal these things, and we're going to try to make another one that we're going to call click obj, obj. And this is going to get the coordinates, and then what it's going to do is it's going to say, look, frog equals frog hop. And now note that it knows what's next. X, Y, distance, delay, line, space, width, and everything, because it's defined in the underscore function. So I have to give it a coordinate, which is going to be X and Y. Notice that self is automatically passed in by Python. So then we get the X and Y. And now I want to give it the distance, but this is the distance string. Then I want to give it the delay string. Then I want to give it the path line string. Then the path space string. I think that was what we did, right? Space string. And then the path width string. And then that's the width. And then the last one is path length. And then finally, the color. And in this case, I'm just going to say random choice of colors. And that should create the frog. So the only thing I need to do is I need to have a click. I need to be able to click the click object. So what I'm going to do down here is I'm going to say, look, let's change this to click. So if I do a button 2 click, I get the old one. And if I do a button 1 click, I get the new one. So we can still draw the old frog that we built manually, but we can also do the first button click button 1 will give us call the, on that click, it will call the click object event, which will get the X and Y and then grab all the data from the GUI and create a frog, put it in a local variable frog that will just sit in memory until the frog gets deleted. And that should do it. Let's give it a try, see how we did. I'm sure there's a typo somewhere. Well, came up. Oh, look at that. It's running. It's working. So if I right click, I get the old one. And if I left click, I get the new one. And they both look pretty much it's the same, but the code is so much easier to read when it's done with this object-oriented method. Now, the reality is all of these things that we've been doing in terms of getting object, this distance.get, these are all objects. Canvas is an object. Everything's object-oriented programming in Python, but you can make your own objects. And it is awesome because this move function, I could have 50 objects with their own move function. And I don't have to worry about namespace because right now this function click and this function hop is a global definition of a function. I have to worry about other people writing a hop function. But once I move that function into the object, everything just works and it is magic. Now, before we wrap up this episode, I actually want to use the program we've written. There's the current object-oriented frog. Here's another object-oriented frog, and here's the old one using the dictionary. I want to spend for a moment and look at how our program actually works, some things that's nice about it, and some things that are problematic that I would like to fix. So the first thing is we're checking the size of the canvas to see if the object goes off the canvas. So one thing you can do actually here is if I make the canvas smaller, they stay on the canvas. And you can see they all get bunched together, but that's nice. So I can make this canvas bigger, right? And now they're wandering around. I can add another frog on this big giant canvas. But here's the problem that I don't like. Okay, so first thing I can do here is I can change the speed of the frogs. So if I change this number to 150, it doesn't affect, these frogs already know how fast they're going. And I can change this distance. So let's say 200 pixels. So I'm gonna go 200 pixels every 150 milliseconds. And let's give me a line width here of 4. And let's do 10 and 10 space. So when I click, I get a frog that moves pretty quickly because he's going so fast. But the reason we called it frog hop is that guy's hopping. And if I make this even bigger, like 400, and I'll slow this down to 300, okay? The frog's not walking. The frog is hopping a very long ways. And I don't really want them to hop that far. I'd like them to walk along a long path and then turn. They're not walking, they're hopping. And in fact, if I set the line length to 0, right, or let's say 1, and I create another frog after it, it's pretty quick. You can't tell where they went because they're not walking, they're just jumping. So if you think about our missile command problem, we're going to try to shoot a missile and have it travel. It can't hop to the top. That doesn't work. We need it to travel. So what we're going to do in the next episode is using object-oriented programming. We're going to create an object that will walk from where it started out to a target location. And then when it gets there, you can do something else, like go to another direction. And so this is what we call the targeted object. So we have a starting point and an ending point and tell it how fast to get from A to B, so that instead of these big giant hops, we can actually have it walk. And so that's what we'll be doing in the next episode. And I'm excited. Hope you are. Thank you.